All right, intermediate algebra homework day 1. Fractional position on the number line. Wants to know what the position of D on the number line is below. Write your answer as a fraction or a mixed number. You're going to have a fraction answer if your value is between 0 and 1. Mixed number answer if you have something bigger than 1. So in this case, the D is past the 1. It's going to be 1 and something, which is a fraction. So what I'm going to do is figure out what the denominator of my fraction is by counting how many spaces are between 0 and 1. There's 1, 2, 3, 4 spaces, so each of my little line is a fourth. So I'm here at 1, I'm going to go 1 and 1/4, 1 and 2/4, 1 and 3/4, so D would be 1 and 3/4 on my number line. Number 2 wants to find the position of C on the number line below. Again, write your answer as a fraction or a mixed number. Since the C is past the 2, again, we're going to have that mixed number because it's going to be at 2 and something. So again, I find my denominator. 1, 2, 3, 4, 5 places. So each of my little lines is a fifth. So here I'm starting at 2, 2 and 1/5, 2 and 2/5, 2 and 3/5. Then it's going to be the position of C. Number 3 wants to know what is the position of F on the number line below. Write your answer as a fraction or mixed number. Again, F is past the 1, so we're going to have the mixed number 1 and something. Finding my denominator. I have 1, 2, 3, 4, 5 spaces. So again, I'm in fifths. So I would start at 1, 1 and 1/5, 1 and 2/5, 1 and 3/5, 1 and 4/5 is where F is located. Number 4 is plotting integers on a number line. Integer is a fancy word for a whole number that can be positive or negative. On the number line, in this case, the zero's in the middle, the positive numbers go to the right, the negative numbers go to the left. So if I'm going to plot -1, I'm just going to go one place to the left of 0 and put my dot. If I'm going to plot -7, I go 7 places to the left. 1, 2, 3, 4, 5, 6, 7. So -7, 7 places to the left of 0. +4, I would go 4 places to the right. 1, 2, 3, 4. So, number 5, I want to plot -6. I know -6 is past -5, so I'm just going to jump to -5, and then one more would be -6. So -6 would be 6 places to the left. -4, -1, -2, -3, -4. There's my dot. And +12, I have to go 12 places to the right. I know it's past 10. 5, 10, 11, 12. So 12 is 2 places past 10. I can put my dot on my number line. Plotting -8 on my number line. Again, -8, I would go to -5, then -6, -7, -8. +11. 5, 10, and one more would be 11. And then the last one, -3. So -1, -2, -3. And I have all of my integers marked on my number line. The next set say plotting rational numbers on the number line. Rational numbers, fancy word for fractions. We're going to plot fractions and mixed numbers on the number line. So when I'm plotting fractions and mixed numbers, I need to know what units my denominator should be in. Just like on those previous ones when I was writing the fractional position, I want to know what my denominator should be. So I'm going to count how many spaces I have between 0 and 1. These are kind of small, but you can see on your paper I have 1, 2, 3, 4, 5, 6 places. So I want my denominators to be in 6. Here it is. It's in -2 and 1/6. So on my number line, I would go to -2 and then one more 6th place to the left. And so I'm going to be right here, one past the -2. Now when I have 8/3, I need my denominator to be in 6th, because that's what those little marks are on my number line. So I need to make my equivalent fraction. 3 divides into 6 2 times. 8 times 2 is 16. Now if I wanted to, I could start here at 0 and count 16 places over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm 4 places past my 2. An easier thing to do probably than having to count all 16 of those little lines is to make your mixed number. If I make this into a mixed number, I'm dividing 6 into 16. 6 divides into 16 2 whole times. I went past the whole number 2. I then check my remainder. 2 times 6 is 12. My remainder is 4. So I have to go 4 more 6. I went 1 6, 2 6, 3 6, 4 6. Notice I ended up in the exact same spot as when I counted 16 little lines. So on number 8 again, I'm looking to see what units I'm going to be in. So I'm going to first count how many spaces are between 0 and 1. 1, 2, 3, 4, 5, 6. So I want to do -1 and 5 6. I'm going to go to -1, 1 6, 2 6, 3 6, 4 6, 5 6. So I should end up on the line right before the -2. 5/3 again, I need to do what I did up here, create my equivalent fraction in terms of 6. 3 goes into 6 again 2 times. 2 times 5 is 10. Instead of counting 10 lines over, I'm just going to go ahead and divide 6 into 10. Goes in there one whole time, and when I subtract, my remainder is 4. So I jump to the 1 and then go 1 6, 2 6, 3 6, 4 6. And there's where my 1 and 4 6 is, or 5/3. Number 9. Here, if I count between 0 and 1, I only have 1, 2, 3, 4 spaces. I'm in fourths. Both of those happen to have denominators of 4s, so I can go ahead and just plot those. -3/4. I start at 0. -1/4, -2/4, -3/4 is right before the -1. On the 7/4, I could either start at 0 and count 7 lines over, or I could make my mixed number. 4 goes into 7 one whole time. I have 3 extra ones, so I want to do 1 3/4. So here's 1, 1/4, 2/4, 3/4, and so 1 3/4 is right before the 2. Number 2 says I'm ordering integers. In other words, I'm going to compare less than and greater than. Less than points to the left. Greater than points to the right. So you want to think about where your numbers are on the number line. If I'm thinking about -2 compared to -1, -2 is on the left of -1. It's going to be less than. If I were comparing, let's say, 2 to -2, 2 is on the right of -2, and it's positive compared to a negative, it's going to be a greater than. So if I'm comparing -10 to -3, -10 would be way down here. It's going to be on the left side. It has a smaller value than -3 does. If I'm at -10 degrees, it's way colder than -3 degrees. If I'm comparing -1 to -4, -1 would be on the right side of -4, which would be over here. Or it'd be a higher temperature. -1 is a higher temperature than -4. Here I'm comparing 7 to -6. Positive number is always going to be greater than a negative number. On the the next one then, if I'm comparing -8 to -2, -8 is lower than -2. It's going to be less than. If I'm comparing -5 to -3, again, -5 would be less than -3. It'd be a lower temperature. And comparing 11 to -6, a positive 11 is going to be greater than a negative number every day. So 11 is greater than -6. Number 12, I'm comparing -4 to -12. -4 would be greater than -12. -4 degrees would be a higher temperature than -12 degrees. Comparing -5 to -2. -5 would be less than -2. And if I'm comparing -6 to a positive 12, a negative number is always going to be less than a positive number. Next one, say we're doing the square root of a perfect square. You do have a square root button on your calculator. If you look at your calculator, there is one there, but probably we could do these without our calculators. We're trying to think of what number times itself gives me 9. We know that 3 times 3 is 3 squared. I'm trying to write 2 there. Is 3 squared. Square roots and squaring are opposite of each other. So the square root of 9 is just going to be the nice whole number 3, because 3 times 3 is 9. The square root of 100. The square root of 100 is going to be 10. 10 times 10 is 100. Or 10 squared is 100. The square root of 36 is going to be 6. 6 times 6 is 36. So squaring and square roots are opposites of each other. So when you're doing those ones with radicals, you're thinking, okay, what number to the second power would give me 9? 3. Absolute value. Absolute value of a number. Absolute values are distances from 0. So when I ask what's the absolute value of -15, I'm saying if I counted on my number line, how many places is a -15 from 0? It's just going to be 15 places, because when I do a distance, I always give a positive value. Here, if I said, well, how far is 9 from 0? It's just going to be 9. If I count it, it's 9 spaces. So when I do absolute value, it always makes my values positive, unless it's 0. 0 is going to stay 0. So the absolute value of -9. How far is -9 from 0? It's 9 places. The absolute value of 11. How far is 11 from 0? It's 11 places. So the absolute value of 6 is going to be 6. And the absolute value of -6 is also going to be 6. They're both 6 places from 0 on the number line. Integer addition, this one says problem type 2 just because it has a little bigger numbers. Integer addition, we want to use our rules for adding. And our rules for adding and subtracting say, if my signs are the same, we're going to add and keep the sign. We already know that if I took 2 plus 3, we're going to get 5. Positive plus a positive is still positive. If I take -2 plus a -3, I owe you $2 and I owe you $3. I'm not going to end up with positive $5. I'm going to owe money yet. I'm going to owe you $5. So when my signs are the same, they're either both positive or both negative, I add the value of my numbers, keep the same sign. If my signs are opposite, we're going to subtract the values of the two numbers and take the sign of the larger. if I have 2 plus a negative 3, I have $2, but I owe $3. I'm going to be $1 short. So what they say is to subtract the values, ignoring the signs. 3 minus 2 is 1, but take the sign of the bigger one. The bigger one's negative, so I'm at minus 1. So now if I have bigger numbers here, 39 plus negative 59. 39 is positive. Obviously, negative 59 is negative. I have opposites. I have $39, but I owe you $59. I'm going to subtract, which is 20, and take the sign of the bigger one, negative. So 39 plus a negative 59 is negative 20. On the next one, I have negative 25 plus negative 37. They're both negative. My rule is to add and keep the sign. I owe you $25, then I borrowed more money and owe you $37. I'm now $62 in the hole. So 25 plus 37 is 62. I got to keep my sign, so it's negative. Number 20. Negative 32 plus a negative 60. They're both negative. I'm going to add and keep my sign. So if I add them, I get 92, and my sign is going to be negative. 57 plus negative 34. I have $57. I've got to pay you $34. I'm still going to have some money left over. I'm going to be in the positive. I'm going to subtract. So I'm going to get 23. Take the sign of the bigger one. The bigger one's positive, so positive 23. Negative 36 plus negative 41 then. Add and keep the sign. If I add them, I get 77, and I'm going to keep my sign, so negative 77. Negative 27 plus 49. I'm going to subtract and take the sign of the larger. So if I subtract those, I get 22. It is positive because my bigger number is positive. The next ones we're doing subtracting on. There's a bunch of different kinds of subtracting, so I just did 2 examples. Well, actually 4, because there's 2 in each one here. First one, talking about integer subtraction. Technically, subtracting is adding the opposite. If you look at the Alex program, they're going to take 1 minus 5 and rewrite it as 1 plus negative 5 and follow those exact same rules we just did for addition. I look at it like this. The 1 is positive because there's no sign in front. The 5 is negative because there's a minus sign in front of it. I'm subtracting it. 1 minus 5 is going to end up being negative 4 because they have opposite signs in front, so I have to subtract and take the sign of the larger. Now in this one, again, technically it means negative 3 plus a negative 8. But why rewrite it like that? This has a negative in front and this has a negative in front. The signs are the same. So I'm going to add and keep my sign. So if I add those, I'm going to get 11 and it's going to stay negative. So negative 11 is going to be my answer. So number 23, I have negative 7 minus 4. They both have minus signs in front. I'm going to add and keep my sign. Negative 11. The next one says 2 minus 5. I have a positive and I'm going to subtract, and so this has opposite signs. I have to subtract and take the sign of the bigger one. If I subtract, I get 3. My larger one has a negative sign in front, so 2 minus 5 would give me negative 3. (24) and 25, this is the place where you actually probably want to use the rule that when I have subtraction, I want to change it to adding the opposite. Whenever I subtract a negative, this is going to change to a plus sign. The opposite of a negative changes it to a positive. So this problem here is going to become 9 plus 5, and so 9 plus 5 is going to give me 14. So anytime I see that minus a negative right in a row, once we have the multiplying rule, a negative times a negative, it changes it to a plus. This problem then is going to be rewritten. Negative 3 plus 1 instead of minus a negative 1. Negative 3 plus 1 gives me an answer of -2. The next one here, I'm going to have -5, and again I have minus a negative, so I change it to +10. -5 plus 10 is going to give me +5. And then this one's going to change to 6 plus 9, and 6 plus 9 is just 15. So now when you get to type 3, now they're going to take all those rules and blend them into a whole bunch of problems, mix them together. If I can get down there. Number 26 then. I have -39 minus 35. They both have minus signs in front. I'm going to add and keep my sign. So if I add those, I'm going to get 74. I keep my sign, so -74 is my answer. On this one, there's one where I have that minus a negative. If I have that, I'm going to change that to a plus. So 5 plus 6 gives me 11. 27, here's one. The first number's positive. I'm going to subtract 49. So since my signs are opposite, I'm going to subtract and take the sign of the larger one. If I subtract, I get 23. The larger number has a negative in front, so -23. And then the next one's one I'm going to have to rewrite. I've got that minus a negative again, so I'm going to take -4 and add the 11. My signs are now opposite, so I subtract. 11 minus 4 is 7. Take the sign of the bigger one, which is the positive 11, so +7 ends up being my answer. And the last three on this page, the rules for multiplying and dividing. Now the rules for multiplying and dividing are not the same as the rules for adding and subtracting. So you have to think about, am I multiplying or dividing, or am I adding and subtracting? For multiplying and dividing, if the signs are the same, we get a positive answer. Now that's if we're only working with two values, and that's what they're assuming. So if I take 2 times 3, I get 6. If I take a -2 times a -3, then I'm still going to end up with a +6, because a negative times a negative is a positive. My two signs are the same. If my signs are opposite. If I take 2 times a -3, whoops, I better put the answer. I'm going to get a negative. So if I take 2 times -3, I'm going to end up with a -6. So if my signs are the same, when I'm multiplying or dividing, it's positive. If my signs are opposite, I'm going to end up with a negative. So on number 28, I have a positive divided by a negative. I'm going to end up with a negative. And then I just divide. 45 divided by 5 is 9. On the next one, I have -6 times -5. My signs are the same. A negative times a negative is a positive. 6 times 5 is 30. Number 29, -5 times 7. I have opposite signs. It's going to be negative. 5 times 7 is 35. -54 divided by 9. A negative divided by a positive is going to stay negative. 54 divided by 9 is 6. Number 30, -27 divided by -9. I have a negative divided by a negative. My signs are the same. It's going to end up being positive. 27 divided by 9, 3. And then on the bottom one, I have a -4 times a -7. Negative times a negative again is a positive. 4 times 7 is 28. And that is the end of the homework page, day 1.